Hello guys, good afternoon. So hi. So hope you guys are doing great. Sufyan Shamal, hi. So yeah, so how was your exams, guys? Hope it went well. Hope your exams went very well. And you guys had a good time with your exams. Yes, guys. So, yeah, today will be I'm Pradeep Kumar again. We are in our physics class again. So we'll be studying. We'll be starting, or we'll be continuing with our physics lectures as scheduled. So we'll be starting with electrostatics again. So there are most of the students are new in this. Like there are many students who have come online via YouTube Live. So there are many students visiting our class. So we will be starting with the electrostatics. We'll be having a very quick recap of what we have studied, and yeah, we'll be going through next topics of electrostatics. Then yeah, once we are done with all theory part, we'll be starting with problem solving. Probably problem solving would be taken done by next classes in the next class tomorrow. Yeah, so I'm quickly launching a technical poll for you guys. Please check whether my voice is audible, if I'm audible clearly and the blackboard is visible, or whatever the screen is visible to you guys very clearly. If anyone have any issue in my hearing, or if you are not able to hear properly, please follow the steps. So at the bottom corner of your screen, at the bottom corner of your screen on left corner, you have a earphone like symbol where it is written join audio. Click on that. Once you click on that join audio, you'll be given two options: dial in or call over internet. Click call over internet, then you'll be starting to listen to my voice or hear my voice. Yes. Yeah, guys. So we'll be starting sharply by 3. We'll be starting sharply by 3, guys. Yeah, we have many students joining us today via YouTube Live from various regions, say Hyderabad region, all over Hyderabad region, like Kerala, Kerala, Telangana, and other regions, other parts, other states. I mean, other districts of Karnataka too. And again, we are live with students from Andaman Nicobar, Genvi, Andaman Nicobar, I guess, and yeah, yeah. And we have students from Shillong region here. Hi to everyone. Hope all of your exams went very well and you are doing great. Yes, guys, come on. So if you're happy and you know it, click on yes. Okay, cool, guys. Hi. So yeah, hope if you have any doubts with your exams, all the Zoom students, you could reach out to me. If you have any doubts in your exams or exam questions, you could reach out to me via my personal WhatsApp number, or you could post your doubts in the groups, whichever you are in. Say right now there are students from 1A and 1B, batch 1A and 1B. These students can post your doubts from whatever the test you had attended today. If you have any doubts, you could post your doubts in the group or to me personally. So I hope you know my personal WhatsApp number. Okay, that's my official number too. You could just drop in doubts there. So all the YouTube live audience, you could ask your doubts via in the chat box. Say you have the chat box there. Try to ask all the doubts you get. Meanwhile, in the course, yeah, whatever the doubts you get, please try to post them in the chat box so that I can read your chat box and answer your doubts. Cool. So there are many students. I'm quickly coming to the students section. So there are some students, or I should say it's many students, have not changed their names with their school names in Zoom. I don't want to read out, I don't like to read out the names of students but I request all students to change their names with their school names by next class. Hope that's very simple, right? I mean, this was instructed to you guys in your WhatsApp chat too from Vishal sir, or any other. All other teachers might have also informed you guys to change that. Please try to do that. Okay. Okay, guys. So it's 3 and we are I'm going to end the poll and hope everyone is able to clearly hear me and all are able to clearly see the blackboard or see the screen which is there. So we'll start the class, guys. Come on. Yes. Okay. So yes. So we started with the chapter electrostatics. What was electrostatics, guys? Reply in the chat box. Everyone, please reply in the chat box. What was electrostatics? We started with electrostatics. What is electrostatics? What do you mean by electrostatics? We'll have a very quick recap of electrostatics now. Yes. What is electrostatics? I want everyone to reply in the chat box. It's guys. Yeah. So yep. I hope all of you have done your exams very well. If exams didn't go well, don't worry. Don't worry. It's always uh, it's always good to start fresh. We'll start fresh. Okay, cool. Yes, correct, Prajwal. So study of charges at rest. This was electrostatics. So I had shown you few um, examples here. So there was a man who was rubbing a balloon to his hair, and his hair attracts the balloon. And there was another guy who was rubbing the comb and brought the comb near a paper piece. It was attracting. We have seen lightning, so how lightning occurs, and we have seen when we rub a balloon and bring that balloon near a faucet where the running water is there, the running water would bend. It change its path. It would bend. So why would this occur? This was the first thing which we started with. So we'll just have a quick view of this. So yeah, hairs get attracted to the balloon because the paper attracted to the comb, and there is lightning, and also there is bending of water when the charged balloon is brought near the water. Why? So this we answered. So when we rub the balloon, our hair gets positively charged because it loses some electrons, and the balloon gains negative charge because it accepts all the electron. It absorbs, or it takes all the electrons with it, right? So that's what we got to see. And when he bought the balloon, when he tried to pull out the balloon, the airs got attracted to his balloon. This was observed. Next, when we rub the comb with the cloth gain the positive charge and the comb gain the negative charge. So what happened? All the electrons from the clothes was absorbed by the comb, or was attracted on the surface of the comb, and the comb got negatively charged. The paper, when we brought the charged comb near the paper, what happened? The charged comb induces positive charge on paper and attracts it. Yes, someone raised the hand. Let me know if you have any doubts. Yeah. So there was lightning. So I had explained how lightning occurs. So when lightning occurs, what happened? So we had many number of clouds. So these clouds, they rub each other, and what they form? They form negatively charged. The negative charges are formed on the bottom surface of cloud. All the positive charges are formed on the surface of cloud. So you could see when there is lots of charge accumulated on the cloud, what happens? That clouds, the lot of negative charges which were accumulated hits the ground, right? So these negative charges which were accumulated on the cloud, this starts to hit the ground. So this is how the lightning occurs. This is what we studied in our very first class. So, and also some of them said, okay sir, always lightning don't strike the ground. Some lightning also move up in the sky. Why? These positive charges which are there always move up in the sky. Okay, so always negative charges always hits the ground, but the positive charges move up in the sky. So this we had learned in our earlier classes. Then when we bought a charged balloon, so when the balloon was rubbed with the cloth, what happened? All the positive charges from the balloon, all the negative charges from the cloth were transferred to the balloon. Now the balloon which was charged, when it was brought near the faucet, the negatively charged balloon attracts the water towards it. How? So we had learned all this. So what was common in all of these examples which we learned? The common thing was, yeah, we could see in all these cases the charges which were accumulated, they were at rest or they were stationary at one point or the other. So we started with the study of electrostatics. As Prajwal said, electro means charges and statics means rest. So electrostatics means the study of charges which are at rest, right? Hope you guys remember this. So we had started with charges. What is the formation of charges? Then we studied electric force. In today's class we will revise all these few concepts of charges and force. Then we'll start with electric field in today's class. Okay, so we had built an atom in our previous class. Hope you guys remember this. So what does a neutral atom consist of, guys? What does a neutral atom consist of? The question is, what does a neutral atom consist of? Yeah, right. Correct. Yes. Yes. So, yes, Srinivas. So, the neutral atom consists of a positively charged particle called proton, negatively charged element particle called electron, then neutral charged particle called neutrons. Okay, neutral. There was protons, neutrons and electrons. Protons was positively charged always, neutron was neutral, and electron was negatively charged or is negatively charged. And we had also learned about their magnitudes. The mass of proton, the mass of neutron, though the mass of proton and neutron are same. And if you see, compare with the mass of an electron, the mass of electron was 10 power minus 4 times smaller. The mass of an electron was 10 power 4 times smaller, right? 10 power 4 times smaller than that of proton, but charge wise both the proton and electron both carry same charge. So what was the magnitude of charge? Magnitude of charge q was given as q. Magnitude of charge q is 1.602 into 10 power minus 19 coulombs. This we had studied earlier. Say for protons, it was by convention, it's positively charged. For an electron, by convention, it is negative charge, right? Yes. Then, sir, how did we get positive charge and negative charge again? So when we, in a neutral atom, if we remove the outermost electron, which electron? We could remove only the outermost electron, the valence shell. In the valence shell, we have the valence electrons. We could remove only them. So when we remove those electrons, remove an electron from neutral atom, what happens? Neutral atom gains a positive charge, right? Similarly, when we remove an, or sorry, when we add an electron to the neutral atom at the valence shell, what happens? The atom gets negatively charged. So this we had learned how how we could form, or how is the charge formed in an atom. Okay, this all we had studied. Next, we had studied about properties of charge. Now guys, if you remember, let me know what are the different properties of charge which we had studied. What are the different properties of charge which we had studied? I want everyone to reply. Yes guys. So hi guys from YouTube live. Hi. So yeah, you could answer this too. So what were we studied about different properties of charges? I'm waiting for answers from everyone. Yes, thank you guys. Cool. Come on, I want everyone to answer here. So I want all students to answer. Try to answer. What were the different properties of charge which we had studied earlier? So we had studied properties of charges, right? Yes, Rashmi. Rashmi had raised your hand. Please let me know if you have any doubts. Yep. Okay, Srinivas, Preksha, Prakash, sorry, Pavan, etc. have answered. Cool. Awesome, guys. So the first property which we studied, yes, Ashwita, right? So the first property which we studied was like charges. When we have two like charges, they always repel, and two unlike charges always attract. Correct, Spurti. Cool. So two positive charges repel each other in a charge-free region. So similarly to negative charges also repel each other in a charge-free region. So a positive, and what can we say about positive and negative charge? The positive and the negative charge always attract each other. Okay, we had learned about these. Then the second property which we learned was charges are quantized. Whenever we have to remove an electron or add an electron, we always add a complete electron or remove a complete electron. Such, okay, this property of charge is always quantized. Correct, Manasa? Cool. So charges are always quantized. So we can always add or remove a complete electron in a from an atom, right? We cannot remove or add half atom, quarter charge, or three quarters charge, right? We cannot. This is not possible. So charge is always quantized. Whenever we have a charge transfer, it's always an integral multiple of n, right? Yes, correct. So yeah, and from this charges quantization, what we can do, we can add or subtract. Correct, Manasa? So we can add or subtract any charge like any normal linear algebra, yeah, like algebra maths. Okay, we can add or subtract any charges. Yes. Next property which we learned was charges is conserved. So what do you mean by charges conserved? So what do you mean by charges is conserved? What do you mean by this? So if we have an isolated system, say if we have a separate isolated system, what is an isolated system, guys? What is an isolated system? Yes, correct, Radhika. Cool. So an isolated system is a system which is separated out or which is undisturbed, which is not at all disturbed. So when we have a not undisturbed item or undisturbed object, so what happens if we consider the net charges? If we consider the net charges on those items or the objects, the net charges always remain same, right? Say we can see in here, we had a sweater, we had a balloon, we had a wall. All these charges, all these consists of equal amount of positive and negative charges. So we can say the charges are conserved. Or what can we say? One more thing. What is charge conserved? So charges can neither be created nor be destroyed. Charges can neither be created nor be destroyed, but can be transferred from one object to another object, right? So charges are transferable. So then we learned about different charge transfer. What are the different modes where we can, okay, we could transfer the charge, guys? Yeah, I want you guys to quickly note down all the three. I mean, let me know in the chat box what are the three modes of charge transfer which we had learned, guys. Come on. So, what are the three different modes of charge transfer which we had learned? So, charges from conservation of charge, we know that, yep, the charges can be transferred from one object to other object. What are the different modes of charge transfer which we had learned? Okay. Srinivas, Ashwita, Arun. Yes, most of you have replied. Yes, correct, guys. Yes, conduction, induction, and friction. Awesome, right? So what was conduction? So for conduction, yeah, we had three modes of charge transfer. One was conduction, next was friction, then it was induction. So what was conduction? In conduction, what happens when a charged ebonite rod, say if we want a charged rod here, so when a charged rod is coming in contact with another uncharged body, say there were two bodies, one is charged and the other body is uncharged, and when they come in contact with each other, what happens? So charge from the charged body moves to the uncharged body. Okay, so for conduction we had studied two conditions is must. What are the two conditions for conduction to happen? What are the two conditions? First condition is it should come in contact. Second condition is yes, there should exist a potential difference. So what is potential difference? So both should not have equal amount of charge. So for now we have not learned potential difference in our class, but since you guys have already studied, it's fine. Let us consider that potential difference as both should not have equal amount of charges. So there should be some difference of charges between two bodies when conduction is happening, right? So what was happening, a charged body would give out all the charges to the uncharged body. For how long or for how much? How many charges would transfer in conduction? Will all say if this ebonite rod had 100 electrons, will this transfer all 100 electrons to this metal sphere, guys? Yes, if this ebonite rod had 100 electrons, will this ebonite rod transfer all 100 charges to the metal sphere? No, right? Yes. Then how much would it supply, or how much would it transfer? How much would it transfer? Yes, it would transfer only the half amount of it, only the 50% of it. Why? Why? It would transfer only the 50% of it, right? In conduction. Why? Yes, one word answer. One, yeah, guys, try to answer this, everyone. Yeah, what is that balance called? So, conduction occurs. So, one thing is conduction occurs until what? So, fill in the blank, guys. Come on. Yes, fill in these blanks. So, conduction occurs until it reaches dash. Conduction occurs until it reaches dash. Yes, Latish, correct. Latish, correct. I'm very happy. So I'm waiting for other students to find out what's the answer. So conduction occurs. Yes, Srinivas, correct. So for how long would? Yep. Yes. Srishti, Prakash, correct. Yes. Yeah, Prajwal, what is that called as? So I want students from YouTube Live to answer this. If you could answer, that would be great. Yes, conduction occurs until it reaches a state of what? Yeah, what is that zero potential difference state called as? It's called as equilibrium, right? Electrostatic equilibrium here. So it should be very precise. I mean, I should say precisely, yes, it is electrostatic equilibrium, not just equilibrium. It should be electrostatic equilibrium. Until then, until both, I mean, what is electrostatic equilibrium? Both the charges should contain same amount of charge, right? Until then, the charge transfer occurs. This was in conduction. So for conduction, it should be in contact, and there should be some difference in charges between two objects for conduction to occur. So conduction occurs until equilibrium state is reached. And one more thing is, whatever the charge is in the charged body, same charge would be transferred to the uncharged body. Whatever charge is in the charged body, same charge is transferred to the uncharged body. This is observed in conduction. Next, guys, what was happening in friction? So what was happening in friction? So in friction, when we bring two non-conductors, here the condition is there should be non-conductors. What are conductors? Conductors are one which have free electrons, right? Non-conductors are the one which doesn't have free electrons, and it doesn't allow the free flow of charges. So when we have two non-conducting bodies, when we rub one non-conducting body over the other, what happens? The electrons or the negative charges present in one body would be occupied or accumulated on the other body. Okay, so this mode of charge transfer is by friction. Next, what is induction? What happens in induction? When a charged body, generally when a charged body is brought near an uncharged body, what happens? Say, I'll be quick. Say I have a charged balloon here. Say I have a negatively charged balloon here. When I bring this negatively charged balloon near a neutral wall, so in a neutral wall, I have equal number of positive and negative charges. Say when I bring this negatively charged balloon, what happens? What happens, guys? When I bring a negatively charged balloon near a neutral wall, what happened? Guys, remember? Yes. So when a balloon which is negatively charged was brought near a neutral wall, what happened? Yes. When a charged balloon is brought near, yeah, yes, correct, Spurti, correct, Srinivas, correct, Tejas. So when a charged balloon is brought near a neutral wall, the negative charges in the wall are repelled, creating a net positive charge. So what happened? The opposite charges, whatever the opposite charges were here, this opposite charges were formed on the surface. The like charges were repelled, and a net negative or net opposite charge was formed on the surface of contact or surface where this charge body was brought. So this mode of charge transfer is induction, and induction is always attractive in nature. Induction is attractive in nature. Remember, guys, induction is always attractive. Okay. So, and in an in the body which is being charged, right, in induction, the net charge remains the same. Say in this case, the balloon is charged, the wall was uncharged. But if you see, if you count the amount of positive and negative charges in the wall, it still remains the same. Okay, this were a few points to take from induction. Induction is always attractive in nature. It's a forced formation of charges where when we bring a charged body near an uncharged body, the like charges in the uncharged body are repelled away, creating a net opposite charge on the surface. This is induction. Cool. So next we studied about force due to a point charge. So we applied Coulomb's law. What did we study in Coulomb's law? The Coulomb's law, to study Coulomb's law, we have to consider 2 point charges, say Q1 and Q2, separated by a distance r. Then Coulomb's law states that the magnitude of electrostatic force between 2 point charges is directly proportional to their product. So the magnitude of 2 point charges, the magnitude of force between the 2 point charges is directly proportional to their product. Then it is also inversely proportional to the square of distance between them. So what is happening? The force between these 2 point charges is directly proportional to the product of these two charges and is inversely proportional to the square of distance between them. Then we can write the force experienced by these two charged bodies as F is equals to K times Q1 Q2 divided by R squared. So this law or this equation was provided by Charles Augustin de Coulomb, the French scientist or physicist in 1700s. So what was K here? K here was a constant called, okay, so it's given as K is equals to 1 by 4 pi epsilon naught, where epsilon naught is absolute permittivity. We had learned permittivity. What is absolute permittivity, guys? What is permittivity? What do you remember by the term permittivity? What do you remember by the term permittivity? We had completed this in the class. Let me know in the chat box what is permittivity. No Spurti. Permittivity. If you have written down the notes, I have given that. Had given what is permittivity. Please let me know what is permittivity. So if you remember, we had learned it using the fog example. So permittivity, yes, correct, Prakash. Yes, correct, Radhika. Dashmi, correct. Yes, correct. No, Shashwita. Okay, correct. Yes, Shashwita, correct. Latish, yeah. So permittivity, what we learned was, so it is the measure of, what can we say permittivity as? Measure of how much the material opposes the electron to the charge to pass through it. Guys, if anyone have missed this, please make a note of it. It is the measure of how much the material opposes the charge to pass through it, or allow it how much say if I have a material, say I have a material here. Now if this is a charge, so if this is a charge, the measure of how much the material opposes the charge to flow, or the measure of how much the charge opposes to allow the charge to pass through it is a permittivity. So what was absolute permittivity, guys? What was absolute permittivity? Okay, okay, we had covered all of these, guys. Yep. Let me know what is absolute permittivity, which we had covered this, right? So yeah, I'm waiting for your answer. What was absolute permittivity? Okay, hope everyone is cleared with what is permittivity first. Let me get reply from you. Please click on S if you have understood what is permittivity. So it is very, very important for you guys for learning the next chapter. Let me know. Please click on S if you have understood what is permittivity. It's a measure of how much a material opposes a charge to pass through it. Okay, cool. Okay, guys, cool. So yeah, a lot of you have understood. Yes, correct. So any doubts so far? Okay. So I'm erasing permittivity. So we'll be learning about permittivity in detail in our next chapter, capacitors. Okay. So the last point was the force between 2 point charges always acts along the straight line which is joining them. Okay. One more thing was, yeah, yeah, this is what we had to learn. So permittivity's value, absolute permittivity, means it's the amount of opposition for flow of charge in free space. What is the amount of opposition in flow of charge? Say if I have a positive charge, say I have a charge q and this is moving in space, how much does free space oppose its movement? Is given as absolute permittivity. Its value is 8.854 into 10 power minus 12 farads per meter. So this much amount, this magnitude of force or this magnitude of charge, this amount of opposition for the flow of charge is provided in free space. Okay, quick points to note from Coulomb's law. So Coulomb's law is applicable only for point charges. Remember this, Coulomb's law is applicable only for point charges. Then the values of Q1 and Q2 should be always taken with signs. Say if I have Q1 as positive and Q2 as negative, we have to consider both the signs in calculation. Then if F is positive, if force is positive, if the force after calculation, after simplification of the calculation, if the force is positive, then we should conclude that the force is repulsive in nature. The two charges are repelling each other. Then if force is negative, if the force is negative, then the force is attractive. If the magnitude of force is negative, then the force between the 2 point charges is attractive in nature. Next, so we had learned about charges placed in vacuum. So the value of K was, when we put the value of epsilon in here, we get the value of K as 9 into 10 power 9 Newton meter square per Coulomb square. Then the force experienced by two charges which are placed in air is given by 1 by 4 pi epsilon naught q1 q2 divided by r square. Now guys, when we keep the same two charges in a medium, what happens? We give rise to a term called as relative permittivity. What is relative permittivity? Now we had completed this in our previous class. Let me know what is relative permittivity. Come on guys, what is relative permittivity? So if anyone of you had missed our classes, you have our YouTube Live 5 channel. You could go there. You could search for physics videos. So all the videos which we had covered earlier is available there. You could go through the class if you had missed any previous classes. Okay, guys. So let me know what is relative permittivity. Meanwhile, yes, yes, correct, correct. Just correct, Prakash. So others. So relative permittivity epsilon r So epsilon r was nothing but, it's the epsilon r is nothing but the ratio of permittivity of an object. Say if I have an object, its permittivity with respect to that of, say we'll take its permittivity as say some small k. I could consider the permittivity of any object as small k. Then how much would it oppose the flow of charge with respect to vacuum? How much does my object oppose the flow of charge in with respect to vacuum? This is called as my what? Relative permittivity. So this is my relative permittivity. Relative permittivity means it's the amount of opposition. Say if I have any object, if this object is kept in free space, then how much does this object oppose the free flow of charge with respect to this free space? Say this is called as relative permittivity. We'll learn about relative permittivity again in capacitors chapter. So relative permittivity is given by epsilon r is equals to k by epsilon naught, where is any k is any medium, k is any medium's permittivity, or yeah, k is any medium's permittivity. Cool. So then the force between two charges, 2 point charges, becomes as F is equals to 1 by 4 pi epsilon naught into epsilon r q1 q2 divided by r square. So we had solved some questions based on this. So next we come to the concept of what is 1 coulomb. So from Coulomb's law, what is 1 coulomb? We can say 1 coulomb is the force. Say if we have two charges having 1 coulomb, when we can say the two charges have a net charge of 1 coulomb if they are separated by a distance of 1 meter and experiences a force of 9 to 10 power 9 newtons. But this was very recently changed. Say on 20th of May 2019 it was changed. The coulomb's definition is the coulomb is defined as the amount of or quantity of electrons or quantity of electricity which is being passed or transported in 1 second by a current of 1 ampere. Say if I have a current, say if I have a body, if I have two bodies, and if there exists, so these two are conductors, if there exists a current of 1 ampere, if there exists a current of 1 ampere between these two bodies, and the number of electrons which is being transported from body A to body B for 1 second, the number of electrons being transported from body A to body B with a current of 1 ampere, this was considered as 1 coulomb. So 1 coulomb means it's defined as the quantity of electricity transported or electrons transported from one body to another body, experiencing in 1 second, experiencing a current of 1 ampere. Okay. So then we got a new value for one charge or 1 coulomb, that is 6.242 into 10 power 18 electrons. So 1 coulomb would be exactly 6.24 into 10 power 18 electrons. Please remember this. Please note this. This is very important. Yeah. So we had learned, we had solved some questions based on this. Okay. Next, what happens when we have more than one charge or more than two charge? What if we have more than 2 point charges? How to calculate? How to calculate in this case? Guys, please reply in the chat box. How to calculate the force between 2 point charges if there are more than 2 point charges? If there are more than 2 point charges, how to calculate the force between them? So this was the last concept chat studied in our previous class. Yes. Let me know how to solve this. Please give me an idea how to solve. So if I know how to calculate for two charges. Yes, correct, Shweta. Yes, guys. So how to solve such cases? How to apply Coulomb's law? So what we have to do, we have to consider two charges. Yes, correct, Srinivas, correct, Shashwita. So we have to consider two charges at a time and find its force then again two charges at other two charges at a time. Say in first case I'll consider q1 and q2, find their force f12. Then I'll consider q1 and q3, find its force f13. Then I'll take q1 and q4, then I'll find f14. Yeah, then what should I do? I should add, say, after considering all four charges, I should find the force vector f1, f12, f13, and f14 and add them. F net is f12 plus f13 plus f14. Correct, correct, Tejas. Yes, this follows the principle of superposition. Correct, correct, Anusha. So, by the principle of superposition, we have to add these forces. We have to find the force between 2 point charges individually, then add their forces vectorially. Yes, so we had solved this question. Okay, now, okay, what was the answer for this previous question, guys? We had solved this. Please refer the previous video for this. Now I want everyone to solve this question. This question is very important. So I have a question displayed on this screen. Hope everyone is able to see this question. Yes, I'm reading out the question. The question says there are four positive charges, four equal charges. Say there is a charge q1, q2, q3, and q4 at four vertices of a square. So four corners of a square of which is 5 centimeters. So there is a square and there are four charges. So all the charges have a charge. So q1 equals to q2 equals to q3 equals to q4 equals to 2 into 10 power minus 6 coulomb. Now these four charges are placed at four corners of a square. Okay, which of what is the radius, I mean what is the distance between two consecutive charges? Its length. The square's length is 5 centimeters. If the length of one side of a square is 5 centimeters, now find the coulomb force experienced by one of the charges due to other three. So what I'll do, I'll consider there's charge q1. Now what is the force experienced by charge q1 due to q2, q3, and q4? Please try to find out. Take a minute of time and try to find out the answer. Yes, I'm quickly launching a poll. For people in Zoom, you could answer in poll. For people in YouTube Live, could answer me in your chat box. Please try to solve this question and answer this. We'll solve this question. Okay, we'll solve this question. So in tomorrow's class, we'll solve more questions. So we'll start with new concept today after this question. Yes. So try to solve. So I received an answer already. Nice. So I'm waiting for more people to answer. Come on. The question goes like this. So I have 4-point charges placed at the four vertices of placed at the four corners of a square of length 5 centimeters. Now what is the net force experienced by q1 due to all other three? What is the net force experienced by q1 due to all other three charges? Yes. Come on, guys. Yep. So I want, okay, if you want me to write down the formula for force, the formula for force is, I'll write down here. F is equals to K times Q1, Q2 divided by R square. Okay, guys, try to answer. So people from YouTube Live, please try to answer. Everyone, I want everyone. People here in Zoom and as well as YouTube Live, try to answer this question. This is one important question. If you have and if you try to if you could answer this question, I would get to know, yes, you have understood this answer. So if you want any help with any of the multiplications, you could ask me. If you want help in multiplication or division or any other mathematical process, I mean, yeah, you have to see, eventually you have to practice this. For now, if you have a calculator, you could try with the help of calculator. You know, you guys know you are not allowed to use calculator, but yeah, for time being you could try using the calculator for fast calculations here. Okay, but don't use calculators in your exams. You for prolonged use, don't use calculators. Okay, so any answer so far? I see 10-12 answers here. Yes guys, come on, you can try doing this, try to solve this. This is, I hope this should be easy. Okay, if you can't answer, if you are not getting any answer from these options, you could try to answer what you are getting. So if you're getting wrong, it's fine. You could try to answer what you have got. You should get something, right? When you try to solve, you should get something. So whatever you have got, please reply it in the chat box, everyone. So people in YouTube live can reply that, answer what you have got in chat box, and people here could also reply. If the answers which are mentioned here are not the answer which you have got, you could reply that answer also, right? You know, on Barbekala. Okay, so far I hope everyone are in a relaxing mode after exam. I guess that's the reason why I feel okay. Okay, sir, please do it all by yourself. So, okay, guys, then I'll do one thing. I'll solve this question for you. So, next questions you have to solve. So, I'm sharing the poll. So, the poll says most of you have answered for C. Okay, I'll keep this. So, most of them have answered for C. Then let's start solving it. So, what's the first step, guys? Come on, tell me step by step. What's the first step? So, there are 4-point charges. Okay, there are 4-point charges. Sorry, Q1, Q2, and Q3 and Q4. And I know all the 4-point charges are having a charge of 2 into 10 power minus 6 coulomb. Correct, Sashvita? Ishwarya, correct? Yeah. So have these 4 charges placed at 4 corners of a square. Now what happens? Each charge is 2 into 10 power minus 6 coulombs. Remember this. Now, first what I'll do, I'll consider 2 charges. Say Q1 and Q2. So I'll consider charges at A and B first. So FA, B, or FQ1, Q2. I'll call FAB. That would be easy. FA and B. So if you observe FA and B, what is the difference? What is the distance between A and B? Guys, reply. Yeah, the distance between A and B is 5 centimeter. Similarly, what is the distance between A and C? Distance between A and C is also 5 centimeters, right? Correct. Now, can I write FAB, whatever the charge between FA and FB would be, same amount of charge would be between FA and FC, right? See, both the charges Q1 and Q2 or Q1 and Q3, magnitude of both the charges are same and distance between them is also same. So we'll solve this. FAB and FAC, both are same. So FAB or FAC equals to what? K times, what is the value of K, guys? K is equals to 9 into 10 power 9. If you remember, it was 9 to 10 power 9 Newton meter square per coulomb square. Right. So I'll write down only the magnitude 9 into 10 power 9 into, what was my Q1? So I'll just, yeah, what was my Q1? Q1 value is 2 into 10 power minus 6. Again, Q2 or Q3, whatever. So both had a value of 2 into 10 power minus 6. coulombs. Now divided by, what is R? R is 5 centimeters whole square. Okay, always consider square, whole square. Now try to simplify this. Help me simplify this. 92, 92, 9 twos are 18, 18 twos are 36, right? So I get 36 into, now let us simplify powers. 10 power minus 6 into 10 power minus 6. What happens? Reply in chat box, guys. Help me solve this, please. So 10 power minus 6 and 10 power minus 6. It is 10 power minus 12. Yes, 10 power minus 12 plus 9. How much is that? 10 power minus 12 plus 9. It's like 12 minus 9. You get minus 3. 10 power minus 3. Yes. That's in the numerator. Now come to the denominator. 5 square. 5 square is 25 into. So what is centi? Centi is, I can rewrite this centimeter as, say, into 10 power minus 2. Now I'll get 10 power minus 4 here. Now guys, 36 by 25. What is 36 divided by 25? 36 divided by 25 whole square. So you'll get 1.414, or sorry, 1.44 into 10 power plus 1. So if you simplify this, you'll get 1.44 into 10 power plus 1. So FAB equals to FAC equals to 1.44 into 10 power 1. That is, okay, I can write as 14.4 newtons. So we'll keep this in a box. This is very important for us. This is 14.4 newtons. Okay, first step is done. Now secondly, so did we calculate all forces? FAB, FAB and FAC is done. Now what about FAC? Sorry, FAD. Okay, we should call FAD. Now what about FAD? If you see this, what about this distance? Which theorem should I apply here, guys? Yes, which theorem should I apply? Pythagoras theorem. So by Pythagoras theorem, the distance between these two, hypotenuse square is equals to opposite square plus adjacent square. Then hypotenuse is 5 times root 2. Okay. Apply Pythagoras theorem, you will get 5 times root 2. Okay. Now FAD is equals to 9 into 10 power 9 into 2 into 10 power minus 6 into 2 into, okay, let me draw a boundary line for that. We should not get confused. Or wait, I'll do one more. I'll take a different color pen for this. Okay, so we have to calculate FAC. Sorry, FAD. FAD was 9 into 10 power 9 into 2 into 10 power minus 6 into 2 into 10 power minus 6 divided by, yes. So 5 into root 2, they have given the value. What is root 2 value? 1.414. Okay, into, okay, this is into 10 power minus 2 whole square. Why 10 power minus 2 whole square? It's centimeters. Now if I solve this, what would I get? So I know numerator value we had already calculated. It is 36 into 10 power minus 3 divided by, if you try to simplify this, you'll get 49.98. So this value is 49.98. This I'll approximate to 50. So I can write 50 into 10 power minus 2. Yeah, now we had squared, right? Yes, we had already squared. So 10 power minus, we would get 10 power minus 4 here. So try to simplify this. What would we get? 36 divided by 50. This is approximately 0.72 times 10 power plus 1. So this is 7.2. newtons, right? Okay, now, so what is my F net? F net, F net, force net equals to what? So I'll change my pen again for F net. So what would be my F net? Oh my god. F net is FAB plus FAC plus FAD. So I should get 14.4 plus 14.4 plus 7.2. How much would I get? I should get, yes, 36 newtons. So option C, 36 newtons is the right answer. Hope all of you have understood this. Hope all of you have understood this. Yes, people from YouTube live. Hope you guys also have understood this. So answer is 36 newtons. Click on yes if you have got this. Click on yes if you have got this. Everyone. Okay, guys. So I request everyone to participate actively. Okay, take a break. I mean, not a complete break, just 30 seconds break. Take a stretch break. And just, yeah, don't go anywhere. Next, would be starting with next concept. So I have a recall test for you guys. Okay. So hope everyone are doing great. Yes. Okay, let's start. Okay, shall we start now? Shall we start with the test? We have a recall test. Yes. Okay. So the first question is in front of your screen, guys. Everyone. The very first question is in front of your screen. The first question is, the force between two charges is given by the dash. So I expect all 100% answer in this. So it's just a test for you guys, how much you remember from what you have learned so far. It's just a test for you guys. Yeah. It would be great if you, I mean, it will make me happy if you answer all. Everyone in YouTube live too can participate here. And reply your answer, please. Reply your answer in chat box. Yeah. Mhm. Yes, guys. Cool. Awesome, Aishwarya. Right. Okay. So I'm going to end the poll. I'm going to end the poll. So why? I hope everyone are still. I see most of you are still in the exam mode or in the relaxing mode. Okay. So the first answer is yes, we use Coulomb's law to find the force between 2 point charges. So the first answer is Coulomb's law. Next, have the next question. The force between two electric charges varies. This is again from Coulomb's law. Yes, again from Coulomb's law. So option A says directly to the distance between them. Option B, directly to the square of distance between them. Option C, directly to the distance between them. Sorry, inversely to the distance between them. And option D, inversely to the square of distance between them. So if you know the Coulomb's law, you could answer this very fast, right? Guys, note what you are answering, because you should read the complete sentence. Yeah, whenever we see, we are bound, right? Like we are humans, we are bound. Sir, okay, square of distance. Yes, this should be the right answer. No. So please read the question very carefully, or read the options very carefully. So this is just like yeah, we'll be getting encountering such errors in J mains too many times. So you should read all the options very carefully. Okay. Okay, guys, cool. So it's 1 minute plus up, and going to end the poll. So most of you have answered option D, and option D is the correct answer. So we know Coulomb's law, F is equals to k q1 q2 divided by r square. So we had the distance between them is inversely proportional to the square. The distance between the force is inversely proportional to the square of distance between them. So option D was the correct answer. Last question, guys. I mean, so the force experienced by an electric charge. So this shows how much you have prepared for next class. Like say you had to study for electric field for today's class. So the force experienced by an electric charge is placed in electric field E is given by F is equals to Q into E. Whether is it true or false? You have to say whether it is true or false. Okay, tell me if it's true or false. Right? So, yeah, the upcoming class syllabus would be very, very important, and I want everyone to pay high attention now. Yes. So, hope we have revised all the concepts which we have learned so far, and we'll be starting with a new concept from here on after this question. So the question is, the force experienced by an electric charge Q placed in an electric field E is given by F is equals to Q into E. Is this true or false? Okay, I'm going to end the poll. So I hope most of you have answered this correct. Yes, the force experienced by the charge in an electric field is given by F is equals to Q times of E. That we'll be studying today. Okay, so it's true. Okay, so guys, now quickly tell me, what do you know about electric fields? So let's come back to the discussions. So we were studying about electric fields. So we'll be studying about electric field from now on. So we had studied about electric charge, how is charge formed, and what is the force between 2 point charges, or what is the force between, say, if I have 2 point charges, what is the force between them? And we have also learned about the nature of force. Now, what we are going to study about a new concept, that is electric field. Now I have a question for you. So what can you see here? You can see in the screen, there are two positive charges, right? There are two positive charges which are coming closer. Now, what happens when two positive charges come closer? Reply in the chat box. What happens when 2 point charges come closer? Yes, guys, correct. So, yes, they repel each other. Correct, guys. Awesome. So, when two positive charges come closer, they repel each other. We know this, but why? Why should they repel? How do they know they have to repel? Yes, there are same charges, but how did they know they are same charges and they have to repel? Yes, two forces. The force is positive. Yeah, in our Coulomb's law we had studied. Yes, if two forces are positive, then there is repulsive force. But how? Correct, Arun. So this was the same question which, okay, this was the same question which haunted Coulomb's too. Like we had Charles D. Coulomb, yeah, the French physicist. He gave the Coulomb's law. F is equals to K times Q1 Q2 by R square. Yes, we know. So when two positive charges come closer, they repel. When two negative charges come closer, they repel. And when a positive and negative charge is near, they attract. Yes, this is true, but why? Was the question asked by many other physicists. The same reaction. Yes. Okay. Why? Even Coulomb had to scratch his head. So yeah, there was Newton. Guys, you had studied about gravitation in our previous chapter. I mean, previous class. In your 11th standard, you had studied about gravitation. So Newton also said, say, the force. There exists a force between the Earth. So there is Earth and there is Moon. Now Newton said, okay, I can predict. I can predict the Earth, or the Earth keeps the moon closer to it. It pulls the moon somehow. Newton said, okay, there exists a force between Earth and moon. Okay, there exists a force between Earth and moon, and Earth pulls the moon towards itself. So I can predict. So I can predict the force between the Earth and moon. So Newton said this. Now, how? How was the question? Yes, Newton. So other physicists said, okay, yes, Newton, yes, we can now predict all the forces, all the planetary motions and stuff. But why is Earth pulling the moon, or with what force? Is there any string connected with the Earth and moon? So we know in our day-to-day life, if you want to pull something, there should be something connected to it. But we don't see anything connected here. Now, why is this existing? So there is no string connected to the Earth and moon. There is nothing. It's empty space. But why is Earth pulling the moon? So then Newton was also surprised, so he had a big question mark with him. So why? Yes, we know. Yes, correct. So today we know there exists something called as a gravitation field. So when there are, so Newton in 1700s again concluded, so when there are huge masses, when there are two huge masses existing in space, they exert a force equals to F is equals to G times, F is equals to G times mass 1 into mass 2 divided by R square. And this force, this force was not an imaginary force, though there exists a force. There is no actual force, there is no physical content between these two, but the one of the mass exerts, say if I consider this as mass 1 and this as mass 2, one of the mass exerts the force, attractive force towards the other in a space. Okay, this was given as gravitation force, or this force was called as the gravitation force. And this pull was given by gravitational field. So say if now, say consider there is no moon, there is only Earth. Will, my question is, there is only Earth and there is no moon now, will Earth exert force even in the absence of moon? Guys, you got my question? My question is, say have okay, let us consider this is mass 1 and mass 2. I have removed mass 2 and I have only mass 1. Does the force of gravity or gravitation field still exist? Yes or no? Yes, they exist. So yes, Newton said, okay, yeah, there exists. And now it was a big headache for Coulomb. What happened? Okay, we know Earth. Okay, Newton gave an expression, so there exists a gravitation field and everything was given. Now Newton had to worry, sorry, Coulomb had to worry. So why did Coulomb had to worry? Okay, Coulomb had to worry. Okay, who would explain this now? I have 2 point charges. Now they repel or they attract. I know they repel or attract. I know how much they repel or how much they attract. I can predict with the mathematical formulas. Now, why? Why do they repel or attract? This was given by Faraday. So Faraday gave a theory called the electric field theory. So what happens? Michael Faraday gave a theory that there exists an electric field in a space between two charges. So Faraday gave an idea. Okay, Coulomb, chill, relax. I'll give the explanation for that. So Faraday came up and said, okay, there exists an electric field between any two charges in space. Say there are 2 point charges in a charge free region in space. Now there exists a force between these two charges. And these two charges, there exists between these two charges, there exists an electric field. So this electric field is invisible to us. So this electric field is invisible to us, but exists without the presence of other charge too. The electric field, the Faraday concluded that, yeah, there exists an electric field between 2 point charges. Now, this 2 point, the electric field which is existing is invisible to us. It's not visible to us, but still there exists that the electric field still exists, and this electric field also coexists without the presence of the other charge. To give an idea, to give a picture how electric field is, Faraday said that the electric field is similar to a spider web. Hope everyone have seen a spider web. Say the electric field is similar to that of a spider web with spider in the middle and web surrounded. The spider in the middle is like the charge itself, and the web surrounded is more like the electric field, guys. So the electric field is not okay. Then he also concluded what? Okay, acha. This electric field is not the electric force. Electric field and electric force. There guys. There exist two terms: the electric field and the electric force. Now Faraday said the electric field is not electric force. It's not electric force, Baba. It's something different. So, but they're related to each other. Electric field is not electric force, but they are relative to each other. Okay, so hope this is understood. What is electric field, guys? From Faraday gave a conclusion that there exists a field between any two charges in a space. The field is invisible to us and it exists without the presence of one of the charge. So even if I have only one positive charge, so if I have only one positive charge, still this positive charge exerts some electric field. Then this electric field is similar to, okay, how does this electric field look? Acha, this electric field looks more like a spider web with spider in the middle and web surrounded. The spider in the middle acts as the charge itself and the web acts as the electric field. And he also said that electric field is not the electric force, but they both are related. See, this is similar to the electric field. Say if I have a positive charge, this positive charge is, yeah, this positive charge is the spider and the web around it. Say if I call this spider as a positive charge and its web around it would become electric fields. Okay, understood, guys? What is electric field? So electric field, we should give a proper definition to that, right? So when yeah, we got to know that when there are two positive charges in a region, they repel each other. One charge pushes the other with a force. When there exists an electric field, so what happens? So when there are two positive charge in a region, let's come back to that. So when there are two positive charge in a region, one charge pushes away the other charge with a force. That force experienced by the other charge is given by Coulomb's law. Yeah, we had learned that. This was given by coulombs, right? The magnitude of charge was given by F is equals to K times Q1 Q2 by R square. Now, the force experienced by the charge due to source charge. So, what we call this charge, bigger charge as, we call this bigger charge as a source charge. Now, there exists a source charge, the force experienced by the charge. So, the other charge which we had, the smaller charge, we call it as a test charge. The charge which we had, the smaller charge, we call it as a test charge. The bigger charge we had, we call it as a source charge. Now, the force experienced by the test charge due to the source charge is given by F is equals to K times capital Q1 into Q2 divided by R square. Then, what can we say about the electric field? Then the electric field experienced by the test charge, this is very important, guys. The electric field experienced by this test charge is given by, is told as, is given by electric field E. Yes, yes, correct. So electric field E is equals to the electrostatic force experienced between these two, or electrostatic force experienced by this test charge. Then the electric field is given by E is equals to F by Q2, where F is the force experienced by this unit positive charge. Then the electric field is given by the expression E is equals to K times Q1 by R square. So we can write E is equals to K times Q1 by R square, or E is equals to F by Q in general. So if F is the force experienced If F is the force experienced between two charges, we know the force is a vector quantity. We know the force is a vector quantity. Then the electric field per unit charge. Say if the test charge is of unit quantity, if the test charge is of unit magnitude, say 1 coulomb, then the electric force or the electric field is given by E is equals to F by Q. From here, I can conclude E is equals to F by Q, and or F is equals to Q times of electric field E. Got this, guys? Let me know if you have understood this. The electric field is nothing but, then we can define the electric field as, electric field is defined as the amount of electric force per unit charge. Finally, we can conclude that the electric field is nothing but the amount of electric force per unit charge. Guys, got this? Click on S if you have understood this. Click on S if you have understood this. So for electric field to occur, we wanted a source charge and a test charge. When we bring a source charge, when we bring a test charge near a source charge, what happens? There exists this this source charge. Say if I have a small test charge with me, when I bring this test charge near this source charge, what happens? This source charge exerts a force on this unit magnitude test charge. Now, this force or this force exerted per unit charge is given as the electric field, and it's given by E is equals to F by Q. Its SI unit is newtons per coulomb. Now, electric field is always represented using the electric field lines. So electric field is always represented using the electric field lines. So it can be assumed that the electrons or electric charges talk using the electric field lines. Say if we have two charges in free space, they charge. Say if I have, okay, if I have a positive charge, source charge here, and say if I have another positive charge somewhere at a very far distance. So these two charges need not come too close. So this charge would always get to know, okay, there exists a positive charge. Without even knowing there exists a positive charge, it will ripple away. Why? How? It could experience its electric field. The electric field from source charge could be experienced and it would move away. Okay. So yeah, if you have understood so far, and in a charge free region, guys, in a charge free region, this electric field is continuous. Okay, we'll learn about it in next class. So yeah, now if you have understood this, then try to answer this question. Guys, if you have understood this about the electric field, what was electric field? Electric field was electric force per unit charge, right? Electric field. So guys, just remember this, electric field is electric force per unit charge. Then if you understood what is electric field, try to answer this question. The question is the magnitude of electric field experienced by a charge. Say I have a charge Q here at point A. At a point A, the electric field due to charge Q is E. Is the electric field experienced by a charge at point A is E. Now, what is the electric field experienced by charge 2Q? Say I bring another charge 2Q here at A. What is the electric field experienced by this charge 2Q because of Q? This is the question. Guys, hope you have understood the question. The question is, so I have an electric field experienced by a charge. So I have a charge, so I'll highlight the charge with red color. So this is my charge. Its magnitude is Q. It exerts electric field E at A. At point A, it exerts an electric field E in this direction. Now, if I bring another charge of magnitude 2Q at this point A, I'll bring this charge 2Q near the point A. Now, what is the electric field experienced by charge 2Q? 2q, how much electric field would 2q experience because of charge q is the question. Okay guys, so I want everyone to try to answer this. Okay, I've got many answers so far. I hope most of you got this. Hope the question is clear with you guys. Guys, is the question clear? Did you understand the question? Yes, no? Any reply? Did you understand the question first? The question is, yes, guys, if you understand the question, you get the answer. Okay, cool. Okay, I'm repeating the question again. So method of, so I have a, so I'll simplify the question. So I have a positive charge here. This positive charge gives electric field E at point A. Now I'll bring another point charge 2Q at point A. What is the electric field experienced by 2Q because of Q? Is the question. Okay, cool guys. So I'm going to end the poll. So I got, yep. So many have answered C. The correct answer is B. So the correct answer is B, guys. Why B? So what they are asking what is the electric field experienced by charge 2Q? Say what happens here? Say I had a charge plus Q, or say I'll take a 1 coulomb charge. A 1 coulomb charge. Now this 1 coulomb charge provides some electric field in all directions, right? Say there exists a point A here. The electric field due to 1 coulomb charge is E. If I call the electric field due to 1 coulomb charge is E, then now what I'll do, near this point A, I'll bring another point charge of magnitude 2Q, or say 2 coulomb plus 2 coulombs. Now, how much electric field will this 2 coulomb charge experience? Reply in the chat box. How much electric field or electric force per unit charge? How much electric force this charge would experience because of plus 1 coulomb charge? So I have 1 coulomb charge here. How much would this plus 2 coulomb charge experience, or the electric field? Guys, reply in chat box. Yes, it will still experience same amount of electric field E. Guys, this charge would still experience same amount of charge or same amount of electric field E because of this 1 coulomb charge. Say whatever the magnitude of charge, say if I have many number of charges also here, the electric field provided by or electric field given by 1 coulomb charge is still same in this point at A. At this region A, say I have a region A here, right? At this region A, at all points of A, the force or the charge, the electric field, the magnitude of electric field from 1 coulomb charge is E at all points of A. Whatever the charge is here, whatever the number of charge here it is, the electric field experienced by all this charge due to A, all this charge due to A would be electric field E only. Guys, understood? Did you understood this, guys? Yes. So this becomes my source charge here, and all other charges will become my test charges. The electric field is not depending on test charge. Yes, correct, Tejas. So whatever the 1 coulomb charge or Q charge which I had, this becomes my source charge. All other charges will become my test charge in this case, in this question only. Understood, guys? ಅರ್ಥ ಆಗಿದ್ಯಾ? Click on yes if you have understood. Okay. So we'll end here. So we'll end our class here. So I'm quickly launching Teachers NPS to you guys who are present in Zoom. So guys, let's discuss few things first. Let's discuss few things. Meanwhile, all others in Zoom could answer the Teachers NPS. We'll discuss few things here. So yeah, I know you guys have completed your exam. You guys have completed your exam and you have to, yeah, you need some time to relax. So guys, please do that. Meanwhile, we'll try to focus on learning more daily. Okay, we'll try to focus on learning daily. So try to come to class regularly and try to learn many things. Okay, cool. Okay guys, so yeah, next thing is, so for tomorrow we'll be solving, okay, we'll complete this set of electric field first, then we'll be having a class for doubt solving. Okay, and also we'll be having a class for problem solving. So tomorrow that is 16th 16/10/2020. So we'll first complete electric field. We'll have a quick recap of electric field. We'll complete electric field. Then we'll start with problem solving. So I'll be sharing you a problem sheet. So I have set of problems for you guys. You'll be taking those problems, solving in your homes. I'll be posting in your WhatsApp notes or WhatsApp group description notes. For people in YouTube, I'll be sending those assignments to you in Telegram group. Okay, so you guys would try to solve them tomorrow and day after tomorrow. So tomorrow, if time permits, we'll be starting with the solution. Tomorrow, if I complete electric field by tomorrow, we'll be starting with problem solving. If not, we'll keep that problem solving part on Monday. Okay, so come prepared to the class next. And yeah, yes guys, so whatever we covered today, this was a quick revision part. We had learned all of these in our previous class. If anyone have missed, and if anyone have appeared for the first time in this class, uh, please try to learn from the previous videos, and we'll meet all of you guys tomorrow again. Okay, cool. So yeah, how was your test? How was your exams going on? So I hope it was everyone had exam of same question paper, or was it different? I know this was cluster level, so I guess it was same for all Hyderabad region students. Yes, Prakash Gowda, you had raised your hand. Prakash Gowda. Yes. Acha. I mean, all had same question paper. So yeah, all students from Hyderabad region, you could drop your message. I mean, you could drop your doubts if you had any in my WhatsApp or in the group. Then others could also, I mean, all other people could drop your doubts in your Telegram groups as well. We will be notifying that. And yeah, yes, if you had any doubts, we'll answer that. Okay, so we'll have a quick recap of electric field tomorrow, and we'll try to complete electric field tomorrow. Then yes, after completion of electric field, we'll start with problem solving for both Coulomb's law and electric field based. So I'll be giving you a series, I mean, set of questions to solve. Try to solve them, and we'll meet again in tomorrow's class, guys. Then, okay. Okay, guys. So was great time. So we'll meet tomorrow again, same time. Till then, see you. Bye, guys. Please note, if you please check for your schedules. I guess there is a change in schedule for. Okay, no, it's not there. So please go to the schedule once. It's shared with you guys in your WhatsApp group as well as Telegram groups. So there is some change in schedule. We'll let you know about the change in schedule. If you have not yet seen, please check the group description, check for the schedule, and keep yourself updated. Okay, guys, thank you. Then we'll meet tomorrow. Bye.